Welcome to my channel Learning Electronic Circuits. Here you can learn more about different electronic circuits, its working principles and the construction techniques. Identification of resistors. All resistors have their own electrical resistance and we know that from its coding. As the resistor is a small component, it prevents writing the values onto their surface. There are through-hole type resistors and surface mount type resistors. The through-hole type resistors have a color coding system to identify them, while surface mount type resistors uses another coding system for reading their values. Metric prefix system. To get the number of zeros in a resistor code, you need to understand the prefixes used in the code. The prefixes used in the metric system are used here to get the power of 10 value for resistor coding. Given below is a table that shows the power of 10 values and their prefixes. Resistor color coding. There are 3, 4, 5 and 6 color band resistors. The band very closest to the end of the resistor is taken as the first color band. It represents the first digit of the resistor value. The band next to it is the second color band and it represents the second digit of the resistor value. The third color band represents the multiplier or the number of zeros to be added after the first two digits. The fourth color band represents the tolerance of the resistor, whereas the fifth color band represents the temperature coefficient of the resistor. In the 5 and 6 color band resistors, there will be first, second and third color bands representing the first, second and third digits of the resistor value. The fourth color band is the multiplier, the fifth color band is the tolerance and the sixth color band is the temperature coefficient of the resistor respectively. For resistor values less than 10 ohms, the third color band is considered as gold and the first two digits should be multiplied by 0.1. For resistor values less than 1 ohm, the third band is considered as silver and the first two digits should be multiplied by 0.01. Resistor color code. The resistor color code for a more commonly used 4 color band resistor is given below. BS 1852 letter coding for resistors. In the British standard BS 1852 code, the decimal point position is replaced by the suffix R for ohms, K for kilo ohms and M for mega ohms, which denotes the multiplier value. The letter R is used where the resistance is less than 1000 ohms. When the numbers come after the letter R, it denotes that the value is a decimal point. It is also used where the value of the resistor is less than 10 ohms. Example 4R7, 3R3, etc. At the end of the code, there is a letter given which indicates tolerance. BS 1852 resistor codes. The BS 1852 resistor code for some resistor values are given below. Tolerance code for resistors. The tolerance code for resistors in the BS 1852 resistor code is given below. Resistance value of potentiometers. Variable resistors or potentiometers are also given their resistance values. They are either written as actual value or as an alphanumeric code, example 10K, 100K, 220K, etc. These are imprinted on the body of the variable resistor or potentiometer. In the alphanumeric system, the potentiometer is denoted by the numbers in the last part of the code. Example MTC 103 L4, where MTC is the make. 103 means 10 followed by 3 zeros, which is 10,000 or 10K. Surface mount resistor coding. Surface mount or SM resistors are tiny resistors that utilize the surface mount technology. These resistors are square, rectangle or oval in shape. They do not have wire leads, but instead have short leads or pins at both ends of the resistor. These resistors are soldered onto the metal pads or tracks on the surface mount printed circuit board. The SM resistors are very tiny components and so their values are imprinted as a code on their body. The most common SM resistor coding system is the 3 and 4 digit coding system. The need for a precise coding system for these resistors led to the introduction of a new coding system called as the Electronic Industries Alliance EIA 96 system. Hello friends. Today we are having some resistors here. These are different type of resistors. We have the metal film type resistors, and similarly some high voltage resistors, and the other type of resistors also here. Each resistor, it has a value, as a resistor value that is built into that. When it's been manufactured, there is a resistor value for each resistor, and these values are actually imprinted as a code because it's so tiny. This is a quarter watt resistor. It's so tiny. We are utilizing a code, a resistor color code, and there is a coding system for resistor values. For each value there is a definite code that is given, that is imprinted on the body of the resistor. Because the resistors are so small, it's ideal to utilize the help of a lens or maybe a magnifying glass like this one. You can use a magnifying glass like this so that you may be able to see clearly what these bands look like. So now let us take one resistor and let us check how we'll be able to identify the resistor. The resistor, as we all know, that it does have a body and the two the wire ends, the two terminal ends, and there is a bulge at both ends, and you can also see the different color coding that is given, that is imprinted on top of the resistor. It's been color coded. So now when you try to read the value of the resistor by using the resistor color coder, you can see that we have the 4 bands that are imprinted on this resistor. So for the first band, it is taken, that is closer to the end, that is taken as the first band. So the band that is near to the end, this is the first band. This one is the first band. The color for that band, it's like a brown color. It's seen as a brown color, and that is the first significant digit of the resistor color code. That it is the significant digit of the resistor. Then comes the next band, that is the second band, which the color shows it's a green band, and that is the second digit. That will be the second digit of the resistor value. Then we have the third band, which is yellow here. It is marked as yellow color here in this resistor. So this third band, it is considered as the multiplier. It's the multiplier band. We also see the fourth band, that is, it's shown here as a golden color. It's a golden color. That is the last band, that is the fourth band. So this is a 4-band resistor. So we now got all the 4 bands. The first band, that is the brown color, which will be the first significant digit. Then the second band, that is a green color band, that is the second significant digit. We also have the third band, that is yellow in color, that is the multiplier band. That is the multiplier band or the power of 10 band. Then we have the fourth band, that is it's a golden, it's seen as a golden color. That is the fourth band, which is the tolerance of the resistor. The fourth band, that is the tolerance. So now we need to check this identified color bands with a standard 4 color band resistor color code. Here we can, in this book, you can see the different colors and the significant digits. That is the first figure and second figure. Then we have the multiplier, and that is the power of 10 value, and the tolerance value. So here we have the first band as the brown color. Here you can see the brown color. So we'll take this first band as first figure, that is the 1. Then the second figure we have the green band. So it's here, you can see the second figure here as 5. So 1, 5, and the multiplier is yellow. So we have the multiplier as yellow, that is 10 raised to 4. Here you can see the multiplier as 10 raised to 4. So you'll be adding 4 zeros into the. Then we have the last fourth band, that is golden color. That is a golden color band. So we can see that will be the tolerance band. We'll be able to understand the tolerance of the resistor. So we have the tolerance value with the gold color, that you can see it is as it's 5% tolerance. It's given as 5% tolerance. As the value of the resistor is taken as 150 kilo ohm. We have the significant value 1, then the second significant value of green, that is 5. So 5 raised to 10 into 10 raised to 4. So that will come as 150 kilo ohm. So this resistor is a 150 kilo ohm resistor. So now we'll check this resistor using the multimeter, and we'll just connect one terminal here and the other terminal here. So it is resistor value is coming around 148. It's around 150 kilo ohm resistor. It does really have a tolerance value of 5%. So it may come near 150 around 150 kilo ohm. That is somewhere near 148 or 149. So close to 149. So because of the tolerance value of 5%. Now let us check another resistor. We will take one resistor and let us find out the value using the code. And it's really difficult to see because it's a smaller resistor. It's a quarter watt resistor, and we'll just place a white background here so that the contrast is better to identify the resistor. You can see the first value, that is seen as gray. The first significant digit, that is seen as gray. That is the first value here, that is shown as gray. Then the second significant value that is shown here as red, and the third value that is a multiplier that is also shown as red. So and we also have the fourth code, the fourth color band, that is the golden color band. So we have all the four color bands. There is the initial gray band, then the red, then the multiplier red, and the tolerance golden color band. Now let us see another resistor. We'll take another resistor from here. You can see another resistor, and we are able to see it very clearly, the significant value, the two significant values. Now we are able to see it very clearly, the two significant digits of the resistor. That is the first value that is shown here as red. The second value is also seen as red. This is the first significant digit. This is the second significant digit. Both are red, and we have the multiplier that is yellow in color, and we have the fourth band that is the golden color band. So we'll just check with the resistor color chart, color coding. When looking at the chart, you can find that the first significant digit, that is red, it is showing 2. The red is shown as 2. Then the second figure, the second significant digit, that is also shown as red. Here the same 2 is the value. So 2 and 2. Then we have the multiplier that is yellow. So the yellow multiplier is shown here as 10 raised to 4. So 2 and 2 into 10 raised to 4. We have the 2 and 4 zeros. So that 220 kilo ohm, that is the resistor value for this resistor, with a 5% tolerance. Because of the golden color band, we have the 5% tolerance here. Now let us check one more resistor. Here we'll take this resistor. It's a bigger resistor, and we are able to see all the color bands. This is a high watt resistor. It seems like a 3 watt resistor. This resistor, and we have all the color bands here. We have all 4 color bands. This is a 4 color band resistor, and we can see the first band as it's shown as a green band. That is the first significant digit, that is a green color. Then the second significant digit, that is a blue color. You can see the second color as blue. Then we have the black color, that is the multiplier band. The third multiplier band, that is showing the black color. Then we also have the tolerance band, that is the golden color band. So now when we check with the resistor color chart, here you can see that the first color, that is a green, that is showing the value 5. Then we have the blue color, that is shown as 6. That is the second significant digit, that is 6. value is 6. Then the multiplier, it's shown as black, so we have the multiplier here as 1, and we also have the tolerance value, that is the golden color band, which is the 5% tolerance. So summing up, we be getting the value like 56 ohm, because we have the first significant digit 5, and we have the first significant digit, that is the green, that is 5, and the second significant digit, which is blue, that is 6. So 56, and the multiplier is nil, there is no zeros, there be no zeros. So then the value comes like 56 ohm with a tolerance of 5%. So that is the value of this resistor. Now we'll go through a different type of resistor, that the resistor values, which is mostly imprinted as an alphanumeric code on top of the resistor. You can see the value to 2K, the 2K that is imprinted on the resistor. You can see the value as 2K, and the percentage is 2% tolerance. I think this one is a make, ICC is a make. Then we have the 2K, that is a 2 kilo ohm resistor, and with a tolerance of 2%. So it's a precision type of resistor, and this follows the BS 1852 code. The value is directly imprinted with a K. 2 and 1 K is the 2 kilo ohm resistor. We also have this resistor, where it's written as 22R. So this also conforms with the BS 1852 coding of resistor. So the R represents the ohmic value, and we also have the value 10%, that is a 10% tolerance. We have the 22 ohm with a 10% tolerance resistor. We now have the potentiometer readings. Here we have the potentiometer. It's used as a volume control. It's a volume control potentiometer. You can see the value. It's written on the other side. Here you can see the value. It's shown here as 47 kilo ohm. That is a total ohmic value from one end of this potentiometer, this variable resistance, from one end of this to this end. This is the total resistance, that is the 47 kilo ohm. And similarly, here you can see the reading that is written on the side. On the side of the potentiometer, you can see the reading. It's written as 220 kilo ohm. It's written as 220 kilo ohm. That is the value of this potentiometer. It's mostly used as volume control knob, and for tone and treble and equalizing controls. So this is how we can read the value. And similarly, here you can see the value that is shown here as 10 kilo ohm. This is the value of this potentiometer. This is the total value of 10 kilo ohm. Here the reading you can see on the side of the resistor. It is right here. It is shown here as 22 kilo ohm. It's 22 kilo ohm value. This is a dual ganged potentiometer. It's a dual ganged volume control knob. It's a ganged potentiometer. And this is a wire wound potentiometer. Here the value it is written on this side. Here the value is shown as 5 kilo ohm. The value is written here as 5 kilo ohm. It's written here as 5 kilo ohm. So the total resistance is 5 kilo ohm. Here also similarly it's written as 5 kilo ohm. You can see this value as 5k. So this is the value of this potentiometer. Here the value is shown here as 1 kilo ohm, 1k. It's a 1 kilo ohm potentiometer. So this is how you can read the values of variable resistor or potentiometers.